Two quick points I wanted to make before we move on. First, I made a big boo-boo in the previous videos, but it wasn't worth reshooting them. So I fixed it by sneaking in some extra code into the push-button binary counter code when you weren't looking. You may or may not have noticed. My mistake was I thought this PIC defaulted to the 16 megahertz clock. It does not. It defaults to a 500 kilohertz clock. 500,000 clock pulses per second, not 16 million. Big difference. And yet even at 500 kilohertz, you could see the need for debouncing. So even more so at 16 megahertz. So I added two lines of code right here, which selects the bank for the OSCON, or Oscillator Control Register. And we then loaded it with the correct byte for setting the oscillator to 16 megahertz. Now you can find all this information on page 75 of your PIC's datasheet. It shows the actual bits in the register and what each bit does. Then, just like any other control register, you just set the bits that you need. Bits 7 and 6 are for multiplying the clock up to 48 megahertz if you want, but you'll read elsewhere in the datasheet that you need an external crystal for that. And I'm thinking none of you are going to need that kind of speed. I'm thinking more than likely you're going to want to slow the processor down to deal with some of the problems the high-speed clock causes. The next 4 bits, bits 5 through 2, are for setting the frequency of the internal clock. So there you have it. Take your pick as to what clock speed you want, and then you can change the bits accordingly. Notice in these bottom two that there's that 1x. There's that x I was talking about. When you see that, it simply means it doesn't matter what bit you put there. Then the last two bits, bits 1 and 0, you set bit 1 to a high and bit 0 doesn't matter, as you can see here. Once we set bit 1 high, we are now telling it to use the internal clock, which is what we want. So if you want, you can use the internal clock at a lower speed, right down to 31 kilohertz. And as we are about to see in the next lesson, there are plenty of reasons why you might want to do this. I also made a mistake during production, which you guys never saw, but I want to mention it because it'll probably be a common mistake. What happened was I had multiple projects open, like you see here. I was working on this one, changing the assembly code, and I would flash the PIC, but it wasn't working. Instead of a binary counter, it was flashing all of the LEDs in blinker fashion. This is because blinker, you can see the project title is in bold, while the others are not. Well, blinker was set as the main project. So that's the program it was flashing to the PIC, not the one I was working on. So to fix that, simply right-click on the project name and select Set as Main Project. This is why now, when I had you making a project, I had you verify that checkbox, Set as Main Project, was checked. So just in case you already had a project file in MPLAB, your new one would be the one getting flashed to the PIC. So hopefully this would save on confusion. I've also uploaded a checklist for making a new project because there was so many steps. So this is a downloadable file as a PDF in the download section of this lesson. All right, let's move along to your first challenge, writing your own code.